Hi everyone. Today I'm going to present the paper Detecting Near Duplicates for Web Crawling. From our last lecture, we learned that near duplicates can be web pages with the same content but different floating ads. Let's start with the motivation of this research. Identification of near duplicate documents is harder than identifying exact duplicates because we need to consider moderate differences while detecting. The elimination of near duplicates has several benefits. It can save network bandwidth, reduce storage cost, and improve the quality of search indexes. It also reduces load on the remote host that is serving such web pages. The paper lists three challenges for a near duplicates detection system. First is the issue of scale. Search engines index billions of web pages, which amounts to a multi-terabyte database. How to scale the detection is a problem to solve. Second is the requirements for detection speed. A crawl engine is expected to crawl billions web pages per day, so the decision to identify a web page as a near duplicate should be made quickly. Lastly, the system should use as few machines as possible. The paper contributes to show that cherry card's SIM hash is practically useful for identifying near duplicates in web documents belonging to a multi-billion page repository. It demonstrates a technique for solving the Hamming distance problem and presents a survey of algorithms and techniques for duplicate detection. The first main section introduces fingerprinting with SIM hash. It is a dimensionality reduction technique. Here is the procedure of SIM hash computation. First, we extract a set of features from the document, and each feature is tagged with their corresponding weight. Now the set of features constitutes a high-dimensional vector. Then each feature is hashed into an f-bit hash value. After all features are processed, a fingerprint is generated for this document. The advantage of the fingerprinting technique is that it requires a relatively small-sized fingerprints. For example, for 8-bit web pages, 64-bit fingerprints are enough. So it helps to resolve the issue of scale with small-sized fingerprints. Before we dive into the algorithm devised for the Hamming distance problem, let me explain what is Hamming distance. The Hamming distance between two equal length strings of symbols is the number of positions at which the corresponding symbols are different. To help you better understand this concept, here is an example of 4-bit binary tesseract for finding Hamming distance. So looking at the pictures, the blue lines is the distance between 0110 to 1110. The distance is only 1 because only the first digit or position of the 4-bit binary is different. So for the red one from 0100 to 1001, it has a distance of 3. We can see that there are 3 digits or positions of the 4-bit binary are different. So it goes from 0100 to 1100 first, and then to 1000, and lastly to 1001. The paper defined the Hamming distance problem as identifying whether an existing fingerprint differs from f in at most k bits, given a collection of f-bit fingerprints and the Cori fingerprint f. In near duplicates detection system, if k equals to 3, then we consider fingerprints differs from the Cori fingerprint f less than 3 bits, near duplicates of f. In practical approach of the Hamming distance problem is to build a sorted table of or pre-compute all fingerprints whose Hamming distance is at most k bits from f. The approach is really time-consuming because the total number of pre-computed fingerprints is prohibitively large. For example, a 64-bit fingerprint with k equals to 3, we need at least 41,000 probes to detect its near duplicates. So the practical algorithm raised by this paper is to solve the problem with a small number of probes and by duplicating the table of fingerprints by a small factor. A generic mathematical model was built to find the optimal number of tables to avoid searching through a large table with a chunk of potential fingerprints. It also shrinks the sizes of individual tables by compression to reduce the load of detection. For example, table sizes for 8-bit documents and 64-bit fingerprints can be shrunk to approximately half their sizes. So the algorithm satisfied the urge to fasten the smart crawling with less probes. So speaking of the relevance to lecture materials, this paper is highly related to what we covered last time. We talked about what is exact duplicates and near duplicates, solutions of both detections, and why do we care about duplicate detection. Relating to the paper, the work is developed for web documents, specifically other than files or emails. The near duplicate systems have been developed for finding related web pages, extracting structured data, and identifying web mirrors. Our lecture also mentioned the solution using an added distance, which is the Hammond distance I just talked about. So why do we need to detect duplicates is also brought up as a comprehensive review of this issue. Successful identification of web mirrors results in smaller crawling, better search results, improvement in page rank, and cost saving, as we won't need human evaluators anymore to do the detection. We can also extract and categorize useful information from similar pages, inferred from technique and clusters web pages on the basis of structural similarity. Other than these two usages, plagiarism and spam detection can also benefit from such duplicate detection technique. Here it comes to the pros and cons of this paper. The paper has a clear structure with corresponding sections and subsections for each of its major contributions. It also provides a comprehensive review of near duplicate detection other than web documents and analysis of the end goal of such detection. The paper not only described the algorithm devised, but also potential applications of this algorithm. It is insightful with extensions on future explorations based on the comprehensive review. However, the paper is published in 2007, so there are already recent papers about improved SIM hash algorithms available. It might not be the best reference now if you want to learn about the newest SIM hash algorithm. I cited a few sentences from the paper directly to conclude the paper. For web crawling, an online algorithm is necessary because the decision to ignore the hyperlinks in a recently crawled page has to be made quickly. The scale of the problem limits us to small-sized fingerprints. Luckily, Cherry Card's SIM hash technique with 64-bit fingerprints seems to work well in practice for a repository of 8-bit web pages. The online algorithm based on Cherry Card's SIM hash technique developed in this paper is proved to work well in practice, solving the issue of both scales and the decision speed. Lastly, here are 3 interesting questions related to near duplicate detection that I want to share with the class. Is it possible to detect near duplicates by document size? If we can, what percentage of variations in length is appropriate? Is it possible to optimize the detection system by categorizing the web pages first, so we can only search those web pages within the specific categories to detect near duplicates? That can save a lot of time. The last one is it possible to devise algorithms to detect portions of web pages that contains advertisements or timestamps? If we can do that, can we simply remove these ads and timestamps first, and then we can just perform the exact duplicates detection instead? This is the end of my presentation. Thanks for listening.